quick, I'm going to plug my two most recent books, and they are a departure from the usual geology because they are astronomical statistics. Now, this one you're looking at right now, these books are 6 by 9, but the originals are 8.5 by 11 for this book. This was never meant to be released when I was in college. This was a hobby of mine. And what I wanted to do was put together the most detailed statistics of astronomical objects within 25 light years of the sun. And at the time, that was all stars. I mean, we knew of brown dwarfs, we knew of, super Jupiters or whatever you want to call them then. But we, we all had already discovered planets at this point, exoplanets, but nothing like this existed. The internet was still young. Was able to get, they did have, I'll show you later. There's a couple sources that were online then, and I used them thoroughly for most of this. A lot of this stuff is my own calculations back when I was really good at math. Now I'm just mediocre at it. But yeah, I'm going to show you the inside of this. Some of these were originally typed on typewriter. So I stuck when I went to when I started doing this in college instead of like off time, like at my grandparents when I would go home and use their typewriter, I decided to stick with Courier New, that font that all typewriters used to use. So I sat here and is this the original one? Yeah. Okay. So I sat there and I typed this all and put it on 3.5-inch floppy disks. I unfortunately have been unable to recover any of those thus far. Over the years, they've been in cold attics and stuff like that, which probably had something to do with that. I'm still trying different drives to see if it'll work, but I fortunately made hard copies of everything. As far as I remember, it was everything. Now, remember, this was just something I did because I thought it was fun to do because I was weird and I'm still weird. And as those of you that have read my books before know that I'm very technically oriented, very statistically driven person. So, I had never really shed this, but I never changed my major in college. I was always going to do geology, but I did take some astronomy and I did take physics because, you know, that interested me as well. So I found this last year in 2023 when I was down in my basement. I managed to keep these the entire time. I was going through some stuff and I found the hard copies. Okay, of the 97 to 1999 stuff. And I mentioned this in a video before, and I was just like, wow, I can't believe I kept this all these years. And the discs. And the pages were in good enough shape where I decided to just, you know, release it. Now, back then, you had to really, uh, I remember going through journals a lot in Illinois State's library. I remember doing that because none of that stuff was online then. And since I had access to it, I figured, what the hell, I'd go for it, right? So everything past this page is the my manuscript scanned. I made 2 volumes. They were in 2 separate binders. Volume 1 was in a black binder. Volume 2 was in a blue binder. I still have them. I'm not going to throw them out. Maybe when I die, someone will just toss them, but at least they're published now. And I'm just going to walk you through it a little bit. I don't want to show you everything that's in here, but you might notice a different name here. That's because I was born Stephen Bauman. Okay. That was my birth name. And then this douche canoe married my mother and adopted us. And so I had his name, excuse me. But back in the end of 1999, wait, where is it? I know it's in here. I know I included it. I legally changed it back because that guy has long since passed and I couldn't stand him anyway. So that's the name change. I scanned it and put it in there. And if you really want to, you could go to McLean County, Illinois, records and look it up. Okay. So, and this, I scanned some of my handwritten stuff too, and some of my sloppy notes just to see, so you can see my thought process, because a lot of the stuff was calculated. It wasn't derived from, because there wasn't a lot of information on a lot of stuff. My sources were basically, at the time, they were basically just um, the exosolar planets catalog, which is included in here. Why? Because the bloody thing's only a few pages. And this is a direct scan from what does that say down there? 1999. Okay, and my little scribbles are on here, my little rough calculations. It was only this big then. That was it. This is still around. They have subsequently gotten a new website domain, and it's much bigger now. And just to prove that it has moved, see that original address is no longer found. When did I pull that? Pulled that on the 17th of December. Okay, so now that you've seen that stuff, I'm going to take you through a little bit of it. I'm not going to show you everything. There's a lot of stars within 25 light years. I don't like the way I originally did this, but I originally did this for me and a couple of my friends. So no table of contents. There's no index. Okay, there's not an updated one either, and I'll explain why. And I divided it between single stars in the first volume and multi-stellar systems in the second part. I didn't do that in the 2023 version, but we'll get to that. And so that's that. Stars within 25, and there's the date, the cover page. That's when I was more meticulous about that stuff. Section, there is a table of contents, but it's at the very end, and it just says what like section 1A1 is and all that stuff. But basically, this is the format. I did a format page for you. I give you some background, classification of stars, the MK system, Hertzsprung-Russell diagram plots, all that stuff. I can't believe I remember. When I started looking at this, so much stuff started coming back to me. Now, this is hard to find, actually. This was easier to locate in the 1990s than it is today online. So, a lot of stars, after their MK classification with the Hertzsprung-Russell luminosity class. Technically, those are two different things, technically, but they're plotted on the same thing. Anyway, it doesn't matter. Our sun is a G2 Roman numeral 5. That's it. It doesn't have any of these. Now, these will appear a lot of times after. Flare stars and emission lines are present. Usually stars with emission lines are flare stars, usually. Peculiarities, broadband absorption lines. Remember, because when we look at stars, we look at their spectrum. We see what elements, that's how we can tell what elements are present in the photosphere of the star. Okay? This one always intrigued me because I never really knew what this one meant. I assumed it means that there's crap between us and the star, like a dust cloud or something like that, really messing it up. And these are still used. All right. In my 2023 version, do not use them. I stopped using them because I just wanted it to be more basic and more, not more basic, but I wanted it to be more easy to understand. This book is expensive, okay? It's black and white because that's all we had. But it's very long. It's in paperback and hardcover. Paperback is cheaper. And like here, I do explain some stuff, like body, suffix, luminosity class, just some basic stuff. Now, the body is actually the MK system, but I don't say that here. I knew that then. This was just generally for my friends as well, not just me, so I had to be a little more pull back. So that's that. Oh, and I have notes down here. Anything in a gray box is a 2023 edition. Addition, not ADD. Okay, and then you see I have single stars. Of course, I start with Sol, the sun. That's the name of our star, Sol, and you can see I have it as a G2.15. Now, the reason why I did that is most astronomers don't do this, and I'm not an astronomer. I tried to fit the square peg into the round hole here because there's supposed to be a basic relationship between what we call luminosity and the spectral classification, the MK and HR thing. Okay, so um, that relationship is not always perfect. And our sun is actually one of those ones where it's not. Most G2 stars are actually a little brighter than our sun. Our sun has a lot of metals in it, which is that it? No. Wait, I don't remember which one it is. Anyway, I'll stop talking. But anyway, yeah, our sun is a G2 star, should probably be more like a G4, G3, but it's not because we go by the spectrum it gives off. Okay, so like I said, they don't always line up. And then I have Alpha Centauri C or Proxima. This was planet known at the time. This is what we thought the orbit was, and I kept it under a single star because back then we still really questioned whether this was gravitationally bound to the A and B component or not. I still have the sinking feeling it's not, but that's just me being biased, but everyone else seems to think it is now. And since these stars were the closest, these were the only ones we really had actual rotation rates for. It's nobody cared about rotation rates of stars back then. They didn't really give two flying F's. Now it's real common. So I guess I kind of saw the writing on the wall here. The reason why no one really did this back then is because it just wasn't worth the effort. We knew how to do it, but we couldn't be that precise to get a very accurate measurement. So this but we tried on the closest ones because we figured, it was worth it. But now tech's a little better. We do this mostly because of exoplanets. We want to roll out rotation period. Okay. And usually rotational period, sorry, you might hear some hissing of cats. um, Usually rotational period is given in kilometers per second. Sometimes it's given in days. But if it's in kilometers per second and I know the circumference of the star, I can easily calculate its rotational period. Now, I didn't do that in this one, but I did it in a 2023 version. Now, I don't want to get too deep into this, but, I just want to show you some stuff. Remember, this stuff was on much larger. I mean, this is 8.5 by 11. This is just the PDF version. It converts everything to 8.5 by 11. Unless it's bigger, then it doesn't. But the book itself is 6 by 9. So it's going to be fill more of the book. Okay. Now, I go through all of that, all those little starsy stars. And I have some black and white drawings for you and some statistical analyses. These are the equations I used. Oh, there's mass temperature. I kept this out of the new one because stuff's easily low. I'll talk about that when we get to that. Hopefully I'll remember. Equations. These are a couple of these I might have derived myself. And a lot of these are just estimates. They're the best we had at the time. I mean, some of them you could algebraically manipulate. Some of them I did for you, like separation of a binary. I did that manipulation for you because Kepler's third law is a period squared is equal to the average separation in astronomical units cubed, and the periods in years. So, yeah, but these are derivations of that. There's a constant involved for each system. The sun is one. Depends on the mass of the body involved. Anyway, and then I go through all the little suffixes here, and there's me carrying pi out. I remember doing this. I would actually type into my scientific, or my, actually, I think I had TI 89 then, or no, in 83. I would actually type all of this into there, every calculation. Now you don't need to. Did it have a pi button? I don't actually remember. It might have had a pi button, then I didn't do it. I was obsessed with Alpha Centauri. And it turns out because there was a lot of ambiguity in the mass between the two, who had what amount of mass. And although we had its orbit down pretty good, we still didn't have it really good. So, and I knew it was coming. I knew that we would be looking at this stuff, that especially Alpha Centauri system, closer and closer because of exoplanets. And we are. We've found some around Proxima. We haven't found any around A and B yet. But these are my margin of errors. Average separation, distance from the sun, mass of the whole system, mass of, as it turns out, I always thought Alpha Centauri A was less massive than everyone else thought it was at the time. I thought it was under 1.1 solar masses, and it is. We know that now. Around that time, a lot of people would a lot of sources would say it was 1.1 or even 1.2 times more massive. And its spectral class is a G25, just like the sun's. Just remember that. So, but turned out I was right on that. B turns out to be almost exactly this. That average, I was almost dead on. For Alpha Centauri A, the average was not. I thought it was closer to the minimum. And actually, I think it's 1.08 solar masses. So I was closer. But this was just me setting the statistical boundaries. And it turns out I was within all, I was within all these error margins. But anyway, so you get to see that. You get to see some of this. Here's the contents at the end of the book. I know, but yeah, there's that. Just so you can learn. And then here we have substellar bodies. Now, I saw the writing on the wall back then that there was going to be a massive gray area between a star, a brown dwarf, and a planet. And I wasn't the only one. A lot of actual real astronomers and astrophysicists knew this back then. It's just we hadn't discovered enough to really, say yes, that start saying substellar bodies instead of stars, So, but and here's something interesting, and I remember doing this. I remember trying to put the dividing line between a star, a failed star, a brown dwarf, and a planet. Okay. Now we have a specific definition of planet. We didn't in the late 90s. That wouldn't come until 2006, I believe. So I went off mass. Anything below a certain mass would have been a planet. Okay. So that was what this was about. I have subsequently, in the 2023 version, abandoned the term failed star, but I don't care if someone uses it. It just seems too sloppy. There's a lot of overlaps between brown dwarfs and true stars. The smallest true stars are less massive than the largest brown dwarfs, and that probably has to do to composition. See, here I am here: terrestrial giant, ice terrestrial, Jovian, brown dwarf, gaseous. Here's me trying to, break out a classification, and then here's me using it. And Pluto was still considered a planet then. But I saw the writing on the wall too, and I think somewhere, oh yeah, here, 12 largest. Okay, so, that wasn't it. Oh yeah, look, Pluto. I call Pluto, where is it? I don't call Pluto a planet. I call it a Kuiper belt. Kuiper, this book contains all my misspellings and errors. I did not change anything from the scans. I only added to the bottom, if relevant. And I'm pretty sure Kuiper's spelled wrong, at least here. But, yeah. So you get all this information as well. And I'm going to stop babbling about this one soon. I'm going to cut this video off before I go to the 2023 version of this. But this stuff, a lot of the stuff I had to calculate. This was not available. NASA did not have this on their website back then, this basic statistical stuff for planets. They do now. But back then they did not. So I had to do a lot of tracking down for this stuff. And it's still pretty close. It's still valid. I do conclude the 8 planets in the new the 2023 version, but I do not have this, the composition. I do not include that. And I did include Pluto as a planet here at the time there, but I didn't on the previous page. I had the feeling eventually it was going to lose its status because we did know, we knew of at least one other Kuiper Belt object at the time, I think. So anyway, that's the first one. So I don't want this video to be 10 gazillion minutes long. So we are going to cut it off there, and I am going to do the 2023 version for you here. And if you could, please look at some of my merchandise I have on YouTube. I also have a Printify, which actually has much more diverse products, and that's at Ezra, that's Ezra's Trinkets, and the same thing with Redbubble. Redbubble is also Ezra's Trinkets. Anyway, that's it. If you have any questions or comments, please leave them below. And I hope if you do decide to get this book or something, it'll be linked, that you get something out of it. But let me know what you think, guys. All right, thanks.